The University of Illinois is very well known for all the work that they've done in pet research. Both canine and feline nutrition work has been done, and so we thought they'd be a great partner to work with. Maria Godoy is the researcher that we worked with at the University of Illinois. She's very well known in this area. Julio was the student that was working on it, and they both were part of helping to put together planning and execution. They did a great job of executing and completing the work. The study design was a 4x4 Latin square where we had 4 different treatments that we were evaluating. That was designed so that each dog would go through each individual treatment and be able to then evaluate it completely. We had a control treatment. We had 4% plasma coated on the outside. We had 4% plasma in the inside going through extrusion, and then also 8% plasma inside for extrusion, for the idea to look at it whether it was having an impact due to extrusion, and then also looking at the impact of level of plasma. Well, we had multiple goals of trying to understand that, one, there's a lot of research done on plasma in model species and also in livestock species. And as we have presented that information out to the industry, a lot of questions have come back about, well, what about in pets? How does it work in pets? So one, that was the goal of this research, was to confirm the effect that we have seen in all these other model species. Secondly, as I mentioned, we wanted to try to look at extrusion. How does extrusion impact it? Is it impacting it? Is it not? We've got a lot of other research showing that we could get through processing and have a beneficial effect, and so we wanted to evaluate that. And then the third question was, with the design, was to look at level. We've seen linear responses in other type of livestock species and models, and so we wanted to look at it in this situation too, to see if the effect carried through in pets. From the extrusion and processing side, we didn't see a lot of differences of that, but what we saw was that we were able to put the plasma through the extrusion process and still maintain the effect. And we saw nice linear effects from that when we were putting in the plasma. With the extruded kibble, we saw improvements in short-chain fatty acids. We saw reductions in some of the phenolics and indole compounds. We saw reductions in blood urea nitrogens. And then also we saw that with the higher level of plasma in the kibble, we saw improvement in fecal IgAs, which all helps to support gut health indicators, and also then we saw beneficial shifts in the microbiome. Well, what it does is it gives the industry an option. Another option to be able to utilize a functional ingredient that helps to support and maintain the gut health with the dog. And along with it, what we've also seen in past research is improving palatability. It's a great protein source. So we've got a lot of other benefits coming along with this data, with supporting the gut and then the other benefits. With this research, the big thing we were looking at was, we've got past research in other species, and we wanted to see if we would have the effect in canine. We get a lot of questions from the industry about that. Other question we get a lot about was extrusion. Could it have an impact through extrusion? And level. So those are the 3 questions that we built into this study to answer. And I feel like the design was done very well in working with the University of Illinois to show this effect, and to be able to show the benefits of having how the level is impacted. We are able to show the benefit through extrusion, and we're helping to support and maintain the gut health. Gut health is kind of the big thing we all think about. I mean, there's the gut-brain axis, there's the gut-skin axis. A lot of things all start with the gut. And if we can help to improve the overall gut, we generally are also helping to improve the overall body, the systemic, everything. And so it's a very key point that people continue to look at and evaluate. Short-chain fatty acids are considered kind of energy source of the enterocytes, so having them going up is beneficial for the gut. Some of the others that we saw, like reductions in blood urea nitrogen, can be an impact on protein metabolism, so again, showing the benefits there. And the other thing with the short-chain fatty acids is they're the effect from the microbiome, so being able to see essentially what we saw there is the outcome of seeing the beneficial shifts in the microbiome. Essentially, we had a linear effect. So, I mean, as we went up from 4 to 8%, those linear responses were noted. And so it kind of depends on what the customer, what level do you want to put in? It depends on what response you're looking for. We got a bigger response. We saw big differences with the 8% versus control, more so than we do with the 4%. So that's kind of what the linear response is telling us. And so it depends on to you what you would like to put into the product. I'd say I'd utilize it and look at how much space do I have in my formula? What am I looking at for protein? It's going to give you some protein with this and good amino acids. It's a very digestible ingredient, so that if you're having issues with that, it's going to help to contribute to that. But then also, as I'm looking at what I can do to help support the gut health, it's a product that can be utilized for that. And along with, as I mentioned, we didn't test it in this study, but palatability, we've seen nice improvements there. So there's a lot of benefits that I would be utilizing with this one ingredient in order to help my product.